In this class, we'll do some questions from the chapter Applications of Derivative. These questions are taken from the last 12 years of IIT JEE or JEE Advanced papers. Here's the first question. Let f1 and f2 be two functions from the interval 0, infinity to r defined by f1 of x equal to integration from 0 to x, the product of t minus j to the power j, where j is from 1 to 21. And f2 of x equal to 98 multiplied by x minus 1 to the power 50 minus 600 times x minus 1 to the power 49 plus 2450, x is greater than 0. Let mi and ni respectively denote the number of points of local minima and the number of points of local maxima of the functions f1 and f2 in the interval 0, infinity. Find the value of 2m1 plus 3n1 plus m1n1 and the value of 6m2 plus 4n2 plus 8m2n2. Here in this question, we are given two functions f1 and f2. We have to find the number of points of maxima and minima. See, the function f1 is given in terms of some integral, but we are not going to use any complicated concepts of integration, as the limit is only from 0 to x. If you differentiate this function, the integral is gone, right? We'll simply get the function inside. If the limit is complicated, we have to use something like the Leibniz rule and all. But here, if you just differentiate, why do you want to differentiate? Because we want to find the maximum or minimum value, so we have to differentiate the function f1. When you differentiate, the integral sign is gone, right? So we will find the derivative of that, equate that to 0 to find the maximum and minimum value, right? But a symbol, right, pi like symbol, that is the product of values, just like sigma, right, the summation of values. Here we have the product of all values, right? Let us find the derivative directly. So I'm writing the derivative of the function f1 directly. So f1 dash, right? So this is the derivative. So that integral is gone. You will get the function inside. The variable of integration t is substituted with the value of x, right? Yes. That means you will get x minus 1. That is the first term. Next term, j is 2. So x minus 2 squared. Next, x minus 3 cube, etc. up to x minus 21 to the power 21. This is the derivative of the function. Okay, yes. Now, if we equate the derivative to 0, because we want the maximum and minimum value, we will get these values for x. So 1, 2, 3, etc. So we have 21 points at which the function can be maximum or minimum, or it can be point of inflection also, right? So these 21 points can be any one of these, right? A maximum or minimum point or point of inflection. Now you tell me, see, the power is even. The moment you get a power even, we can say that it is a point of inflection. So when the derivative has an even power, any factor has an even power, so at that point it will be a point of inflection. So that means 2, 4, 6, 8, all even values of x, we have a point of inflection, okay? But the remaining values, 1, 3, 5, all odd values. So there we have either maximum or minimum, okay? How many points are there? So there are totally 21 points. That means, so 2, 4, 6, 8, so up to 20 even values. So 10 even values, which means in these remaining 11 values, we have either maximum or minimum. But at how many points it is maximum, at how many points it is minimum, that we have to find, right? Yes, let us find it. Let us draw this graph roughly to get an idea. So these are the points 1, 2, 3, 4, etc. Okay, up to say 21. Okay. Now at the point 1, okay, is it minimum or maximum? Okay, you see, when x is less than 1, okay, when x is less than 1 and greater than 1, we will check the sign of this expression. If it changes from negative to positive, it is minimum, point of minimum. Positive to negative, it is point of maximum. Let us see. When you take x less than 1, so this value will become negative. And this is anyway positive, thus you leave all the even powers, right? Now x minus 3, again it is negative, so negative, negative, again negatives. How many negative terms are there? See, as we know already, so all the even powers, okay, there are 11 terms with even power, sorry, 10 terms, so leave all these 10 terms. So remaining we have 11 terms, so these 11 terms are negative, because x is less than 1, negative, 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 so negative terms, like 11 negative terms. If you multiply, you will get negative value. So when x is less than 1, it is negative, which means the slope will be like the slope is negative. And greater than 1, it is positive, right? So this value will become positive and the remaining 10 terms will become negative. So that means the totally it is positive, which means after 1 it is increasing, okay? It increases after 1, okay? Now at the point 2, it is point of inflection. That means it is neither maximum nor minimum. So it is a point of inflection. So that means it again increases, okay? It doesn't come down, right? Then it will become maximum. Now at the point 3, it will be a point of maximum. Okay, so we can check that. Take a value less than 3, greater than 3, it will change sign from positive to negative. So it is the maximum point. At 4, again it is a point of inflection, because even power, point of inflection. At 5, it is a minimum value. So the function attains minimum value at 1 and 5 and many more points, right? So minimum at x equal to, what are the points? 1, At 1 the function is minimum. At 5 also the function is minimum. The next point 9. Okay, interval of length 4, right? So 1, 5, 9. So 9 plus 4, 13. And then 17, 21. So there are 6 points at which the function is minimum. Okay, so done. Now similarly, maximum at the remaining points. Okay, the only odd values, right? 1, 5, 9. So these values are gone. So remaining 3. 3 plus 4, 7, 11, 15, 19. So these are the points at which the function attains maximum value, right? These points, 3 and then 7, etc. So at how many points the function is minimum? 6 points, and maximum 4 points. So that is what is denoted by the symbol, say m1. So n1 is the number of points where the function is minimum. So that is 6. And n1 maximum. So that is 5. So that's all. We can just substitute these values, right? m1 is 6, n1 is 5. We can get the answer to the first question. I'm not doing the substitution. You simply substitute this value, we will get our required answer. And similarly, now we take the next function. So the next function is given. Okay, now let us find the derivative of the next function, f2-x. Let me write the derivative directly here. Alright, so this is, okay, 98 multiplied by 50 multiplied by x minus 1 to the power 49 minus of, okay, so the next one is 600 multiplied by 49 x minus 1 to the power 48. That should be equated to 0. Okay, so the derivative of the function I have written directly. So this is the derivative. Let us find the value of x satisfying this. We can take out common factor 49, or you can even take 98 multiplied by 50. Okay, so take this out. So we will get, we can also take x minus 1 to the power 48. So we will get x minus 1. Now we have taken 98 multiplied by 50, or 49 multiplied by 100. So 49 multiplied by 100, which means 6. So x minus 1 minus 6. So we'll write it as 7, right? So total. So that's all. So this is the derivative. So if we equate that to 0, we will get 2 points, 1 and 7. So these are the points at which the function can be maximum or minimum or point of inflection. See, the power is even. When the power of the factor is even, so that point is a point of inflection. So this is the point of inflection. So 7, at 7, is it minimum or maximum? See, take a value less than 7. If you take a value less than 7, substitute here, so that will become negative. Less than 7, minus 7. So negative. And greater than 7, positive. It changes from negative to positive. Negative to positive means, right? So negative to positive, so that means it is a point of minimum. So the function attains minimum value. So minimum value at x equal to 7. So 7 is the point of minimum. That means only one point of minimum. So that means our notation m2. So m2 is equal to 1. But there is no point of maximum. Okay, n2. So that is 0. So m2 is 1, n2 is 0. So you just substitute these two values in the second question, right? We will get our required answer. So that's all. So that is the answer. Let the function f from R to R be defined by f of x equal to x squared minus 3x minus 6 divided by x squared plus 2x plus 4. Then which of the following statements are true? Here we have a function. We have to find the interval in which the function is increasing or decreasing. Obviously we have to find the derivative. Derivative is positive, increasing, negative, decreasing. Alright, let us find the derivative of the function. So the function given here is f of x equal to x squared minus 3x minus 6 divided by x squared plus 2x plus 4. We have to find the derivative of this. So u by v, right? The quotient rule, we have to use it. But before finding derivative, shall we simplify this? You can write this as x squared plus 2x plus 4 minus of, okay, minus of 5x plus 10 divided by, so x squared plus 2x plus 4. So I've written this numerator polynomial, split it into this, right, so that we can cancel this, right? X squared plus 2x plus 4, here also same value. So that means you will get 1 minus, say, 5 multiplied by x plus 2 divided by x squared plus 2x plus 4. Okay, so this is our required function f of x. We can find the derivative of this. You can directly also find the derivative, right? U by v, so not a problem. But this becomes a linear expression, so it is somewhat easier compared to this, right? Yes, now let us find the derivative of this. So f dash x equal to, so this derivative is 0, so x squared plus 2x plus 4 squared. Okay, so if you take minus 5 out, you will get x squared plus 2x plus 4 minus of this value x plus 2 multiplied by, this is 2x plus 2. Okay, So this is the derivative. Now we will see where it is positive or negative. Now first of all we will simplify this. So this is minus 5 multiplied by x square plus 2x plus 4. This is minus 2x square and then 4x plus 2x, so 6x, so minus 6x, and then 4, so minus 4. I'm not writing the denominator, right, because denominator is anyway positive, right? Only numerator you have to check whether it is positive or negative. So because the denominator is positive, we can leave that, right? Yes, now let us simplify this. So we will get x square minus, so 2, so 5 multiplied by, so this is x square plus 4x. Okay, so that's it. So we'll get x multiplied by x plus 4. This is the given expression with the denominator which is always positive. Okay, now we have to see where this function is negative or positive. X multiplied by x plus 4, right? So that means the function is negative between these values, right? Minus 4 and 0. So the function is negative between minus 4 and 0. So the rest of the values it is positive. Let us draw the curve. So minus 4 and 0. In this interval the function is decreasing because it is negative. So that means what is the value at 0? The value of the function at 0 is minus 6 by 4 or minus 3 by 2. What is the value of the function at minus 4? If you substitute minus 4, you will get 10 divided by 12, right? 22 divided by 12. So we can get the value, so 11 divided by 6, which is more than 1, right? So this is a decreasing function in that interval. Okay, between minus 4 and 0 it is a decreasing function, and then the other interval it is increasing. Okay, now what is the range of the function? Is it infinity? Does it reach infinity? As x tends to infinity, will it go till infinity? So let us see. What is the value of this expression when x tends to infinity? Limit, we have to find the infinite limit. So what is the value when x tends to infinity? See, both these polynomials are of same degree, leading coefficient 1 divided by 1. So 1 is the limit of the function as x tends to infinity, which means this function reaches 1. Okay, as x tends to infinity. So it doesn't go to infinity. Okay, when x tends to infinity it can be maximum 1, that's all. Okay, similarly for negative value also it reaches 1. Okay, when x tends to minus infinity this expression tends to 1. So this is roughly the graph of the function. That means what is the range of this function from this? So this is the least possible value, right? So minus 3 by 2 and the maximum value is 11 by 6. So that means the range of this function is from minus 3 by 2 to that value, so 11 by 6. So that is the range of the function. So that means it is not an onto function. It does not cover the entire real line. So only this is the range, minus 3 by 2, 11 by 6. Alright, so that means it is not an onto function, and also the range given in the option, so that is minus 3 by 2 to 2. So that is also not correct. Alright, so minus 3 by 2 to 11 by 2, that is the range. It is not onto, and this function is decreasing in the interval minus 4 to 0. That means it is decreasing in the given interval, right? Minus 2, 1, because minus 2, 1 is here. Okay, in this interval, so minus 2, 1, in that interval it is a decreasing function. Yes, similarly from 1 to 2, okay, from 1 to 2 for any positive value it is an increasing function. So particularly 1 to 2 it is an increasing function. So the function is increasing in the interval 1, 2 and decreasing in the interval minus 2, minus 1, right? So that's all. So that is our required answer, right? If the function f from R to R is defined as f of x equal to modulus of x multiplied by x minus sin x, then which of the statements is true? A function is given modulus of x multiplied by x minus sin x. We just need to check whether it is an injective or surjective function. See, f of x is given to be modulus of x multiplied by x minus sin x. Okay, now our first aim here is to remove this modulus. So let's consider two cases. For positive values it is simply x, so x minus sin x. So this is for positive values of x, right, greater than equal to 0. So for positive values of x, modulus of x is just x. Similarly for negative value it is minus x multiplied by x minus sin x. So x is less than 0. Now to check whether this function is one-to-one or not, we will find the derivative of the function. If the function, it's already a continuous function, if the function is an increasing function or decreasing function, so that will be an one-to-one function. So that means we will find the derivative here, so f dash x, right? So that is simply, so x square has derivative 2x minus x sin x. X sin x has derivative sin x minus x cos x. This is for positive values of x. So we should not write this equal to sign here because at 0 we are not sure whether this function is differentiable or not. So at 0 we don't know the derivative, so we'll only write for positive values. Similarly for negative values, so the same thing, negative of that. So it is minus 2x plus sin x plus x cos x. So this is the derivative when x is negative. Okay, so is it always positive, this whole expression? Is it always positive or always negative? We will rewrite this. So we can write this 2x as x and this sin x, so minus sin x, and this x we can combine with this. So if you take out this x, so 1 minus cos x. So this is when x is greater than 0. Similarly, negative minus of x minus sin x minus x multiplied by 1 minus cos x when x is less than 0. So this is the derivative of the function. Is it always positive? So as we know, x minus sin x, x is greater than sin x for positive values of x, right? So from the graph of sin x and x, we can understand that this is the graph y equal to x. Similarly, sin x curve is like this. For positive values, sin x is always less than x. So sin x is always less than x. That means x minus sin x is always positive. And 1 minus cos x is positive anyway, so x is also positive. So positive value, the whole expression is always positive for positive values of x. What about this value, x minus sin x? Is it positive or negative? See, for negative values, so this is sin x curve, so sin x is greater than x for negative value. So that means this is negative. But already there is a minus sign, that means the whole value will become positive for negative value. And x is already negative, so minus of x, that will become positive. So this is positive. So the whole expression is again positive. So whether x is positive or negative, so this derivative of the function is always positive. So we understand that the derivative of the function here is always positive or equal to 0. At 0, it may be 0. Now, derivative is always greater than or equal to 0. So that means it is an increasing function. So this function given is an increasing function. So roughly the graph will be something like this. At 0, the value of the function is 0, and then for positive value it is an increasing function, for negative value also increasing function. Okay, it is an increasing function, so obviously this function is an injective function or one-to-one function. Okay, so this is a one-to-one function. Is it onto function? So onto function, the range must be equal to the codomain, which is equal to the whole real line, right? Yes. Now see, as x tends to infinity, so what does it tend to? As x tends to infinity, this value is positive, right? For positive value it is positive. X tends to infinity, so the whole value will tend to infinity, so it reaches infinity here. And for negative value, so for negative value, this reaches infinity, but this will be negative. For negative value, x minus sin x is negative, and this is infinity, so negative infinity. For negative values of x, it is negative, so minus infinity. So that means this function, okay, this curve covers the entire real line from minus infinity to infinity. So that means the range of the function is the whole real line minus infinity to infinity. That means this function is onto also, right? So this function is both one-to-one and onto, right? So that is the answer. Let the function f from the interval 0, pi to r be defined by f of theta equal to sin theta plus cos theta squared plus sin theta minus cos theta to the power 4. Suppose the function f has a local minimum at theta precisely when theta belongs to the set lambda 1 pi, lambda 2 pi, etc. up to lambda r pi, where 0 less than lambda 1 less than lambda 2 less than etc. up to lambda r less than 1. Then the value of lambda 1 plus lambda 2 plus lambda 3 up to lambda r is. Okay, so let's find the point of minimum of the given function, right? So the function given here is f of theta. So that equals sin theta plus cos theta squared plus sin theta minus cos theta to the power 4. Alright, so now to find the minimum or maximum value of the function, we have to differentiate this, but before that we will simplify this function, right? So sin theta plus cos theta squared, so that can be written as, so this is sin square theta plus cos square theta, which is 1 plus 2 sin theta cos theta, so that can be written as sin 2 theta. Alright, plus similarly, so this is power 4, so we first square this and then again we can square it. So sin theta minus cos theta squared, so that is sin square theta plus cos square theta, which is 1 again, minus 2 sin theta cos theta, so that can be written as sin 2 theta squared. Alright, yes, so this is our required function. We will simplify this further, so that can be written as, so this is 1 minus sin 2 theta squared, so this is sin 2 theta squared. So sin square 2 theta plus sin 2 theta, here we have minus sin 2 theta, so we can write minus 2 sin 2 theta, so we'll get minus sin 2 theta and 1 plus 1, so that is 2. So this is our required function f of theta. Now to find its minimum value, we have to find the derivative of this, but we're not going to use the derivative method. This is a quadratic expression in sin theta, right, sin 2 theta. So what you do, instead of the differentiation method, we can use the completing square method. We will complete the square. So this can be written as, right, a perfect square like this one, sin 2 theta minus 1 by 2 squared, right, and 2 minus 1 by 4. So that is 7 by 4. Alright, so this is the function. Now we can directly write the minimum value of the function. So this expression will have minimum value. See, this is the square of an expression. So square of something has minimum value 0. So this is 0. That is when the whole function will become minimum value, right? Yes. So what is the minimum value of this? So when this becomes 0, so that means sine 2 theta equals 1 by 2. So for minimum value, so sine 2 theta must be equal to 1 by 2. So let us find all the values of theta. So 2 theta can be equal to, so pi by 6, and also second quadrant pi minus pi by 6. So that is 5 pi by 6. And there are many more values, right? 2 pi plus pi by 6, but that will exceed our limit, right? Theta lies between 0 and pi only. That means 2 theta cannot exceed 2 pi. So theta values are, so pi by 12 and 5 pi by 12. So these are the values of theta, but these values of theta are given like lambda 1 multiplied by pi and lambda 2 multiplied by pi, etc. Only two values, right? So what is the value of lambda 1? So then 1 by 12. Similarly, lambda 2 is 5 by 12. So that means we can simply add these two values. So lambda 1 plus lambda 2 equals simply 1 by 12 plus 5 by 12. So that is 6 by 12. So that means we get the answer 0.5. So that's also, that is our required answer, 0.5. So that is the value of this lambda 1 plus lambda 2. Okay, yep. Consider the rectangle lying in the region x comma y belonging to r cross r, 0 less than x less than equal to pi by 2 and 0 less than equal to y less than 2 sine 2x, and having one side on the x-axis. The area of the rectangle which has the maximum perimeter among all such rectangles is. Here we have a rectangle drawn inside a region where x lies between 0 and pi by 2 and y lies between 0 and the curve 2 sine 2x. So this rectangle should have maximum perimeter. So let us find the perimeter of this rectangle and find its maximum value. So let us take one of these vertices on the x-axis to be at a distance x from the origin. Similarly, the other vertex on the x-axis at a distance x, same x from pi by 2, because by symmetry both these lengths are equal. Alright, that means the base, right? So one side of the rectangle, so that has length, the total length is pi by 2 minus 2x. So that is one side of the rectangle. Similarly, the height. So this value, this vertex lies on the curve. So that means, so that height is 2 sine 2x. So that means the length, breadth, everything is known. So that means we can find the perimeter of this rectangle and then we can find the maximum value of that. Alright, so let us find it. So the perimeter of the rectangle is given by, so the perimeter, so let's call it P. So that is 2 multiplied by pi by 2 minus 2x. So that is the base length, pi by 2 minus 2x. So 2 times that, right? So these two sides of same length. So pi by 2 minus 2x plus similarly the height. So that is 2 sine 2x. Or that should be multiplied by 2. Okay, so this is the sum of all four sides of the rectangle. So that is the perimeter. Let us find its maximum value by differentiating. So let us find the derivative. So dp divided by dx. So that is, so this is 0. So minus 4. This is 4 sine 2x. So that means plus 8 cos 2x. So equate that to 0. So that will give you the value of cos 2x. So cos 2x equals, so 1 by 2. So we've got the value of cos 2x. Let us find the value of x. So 2x equals, so pi by 3. Okay, so that will give you the value of x, pi by 6. So this is the value of x for which this function attains the maximum value, or maximum or minimum. So you have to find the second derivative actually. We are not going to do that because the cos 2x, so that has derivative minus 16 sine 2x. So that value is negative. So that means this has to be the point of maximum. So this is the point at which the perimeter is maximum. We don't want the perimeter, we want the area for which the perimeter is maximum. Alright, yes. Now let us find the area of the rectangle. So area formula is what? So length multiplied by breadth. So this multiplied by this. So pi by 2 minus 2x multiplied by, so this length is 2 sine 2x. So let us substitute these values, right? So we found the value. So 2x is pi by 3. So pi by 2 minus pi by 3 multiplied by, so sine 2x is pi by 3. So that means 2 multiplied by root 3 by 2. So that's also, that is our required answer, right? So this is pi by 6 multiplied by root 3. Or we can say it is, so this is 3 multiplied by 2. So this is pi divided by 2 root 3. So that's it. So this is the required area of the rectangle when the perimeter is maximum. Okay, so that is our required answer, pi divided by 2 root 3. For a polynomial g of x with real coefficients, let mg denote the number of distinct real roots of g of x. Suppose S is the set of polynomials with real coefficients defined by S equal to x squared minus 1 squared multiplied by a0 plus a1x plus a2x squared plus a3x cube. Then the minimum value of m f dash plus m f double dash where f belongs to the set S is. A set S is given which contains some polynomial functions of this type. Our function f is also one member of this set, so f of x is also of the same type. So f of x can be written as, we can factorize it, x squared minus 1, that can be written as x minus 1 multiplied by x plus 1 squared, again multiplied by another polynomial a0 plus a1x plus a2x squared plus a3x cube. So this is the function f of x. This equation f of x equal to 0 has roots 1 and minus 1 obviously, right? But there is a square, so that means it is a repeated root 1 comma 1 and minus 1 comma minus 1. So 4 roots are already there for the function f of x. It is a repeated root. What is the meaning of repeated root? See, f of x equal to 0, that equation has roots minus 1 and 1. So that means the curve passes through the point 1 comma 0 and minus 1 comma 0, right? So it intersects x-axis at these points. But it is a repeated root. That means not only f of x equal to 0, the derivative f dash of x equal to 0, that equation also has roots 1 and minus 1. Do you understand? That is the meaning of repeated root. So that means the graph will be something like this. So the derivative also has a root here. The slope becomes 0, right? Slope at this point is 0. Slope of tangent is 0 because the derivative is also 0 at those points. Okay. Now, if you observe from the graph, this is the graph of y equal to f of x. Okay. Now, if you observe from the graph, between minus 1 and 1, there is one point at which, again, the derivative is 0. Call it alpha. Not only minus 1 and 1, so there is also a point, say alpha, at which the slope becomes 0, which means the derivative becomes 0 at 3 points. Minus 1, 1 and also alpha. So that means the derivative f dash of x equal to 0. That equation has roots minus 1, 1 and alpha. So the derivative has minimum number of roots 3, right? Now similarly, let us draw the graph of y equal to f dash of x. So let us draw the curve. Now this derivative has 3 roots, minus 1, alpha and 1. That means the curve will pass through these points. Now if you observe the graph of f dash of x, here between alpha and 1 there is a point at which the derivative becomes 0. Derivative of the derivative. So that slope is 0. Or by Rolle's theorem, these two values are equal, right? F dash of 1, f dash of alpha, both are 0. That means there must be some point in between at which the derivative becomes 0. Do you understand? So that is this point. From the graph we can easily observe. So there is a point between 1 and alpha at which the derivative of this is 0. That means the second derivative becomes 0. So let us call that point, say, beta. And also there is a point here, call it gamma, at which the derivative of f dash of x becomes 0, which means f double dash x, right, equal to 0. That equation has roots. That equation has roots, this value, beta and gamma, which means minimum number of roots of the second derivative. So that is 2. Similarly, minimum number of roots of this equation f dash of x equals 0, so that is 3. So that is what is denoted by the symbol, say, mf dash plus mf double dash, right? This is the number of roots of the function f dash x equal to 0. Similarly for the second derivative. So this is minimum value 3 and this has minimum value 2. So that means there must be 5, right? 5 roots for the derivative of the function and the second derivative of the function. So that is our required answer, right? mf dash plus mf double dash has minimum value 5. Okay. Let the function f from R to R be defined by f of x equal to x minus 1, x minus 2, x minus 5. Define capital F of x equal to integration 0 to x f of t dt x greater than 0. Then which of the following statements are true? Here we have a function given in terms of an integral of another function. We have to find its maximum minimum values. This is a very simple integration, no complicated methods of integration, because the limit here is 0 to x, that's all. Now if the limits are complicated expressions, then we have to use the Leibniz rule and other properties. Now here simply we have to know the fact that the derivative of an integral of a function is that function itself. So let us use that method to find the derivative of this function capital F of x, because we want to find its maximum minimum values. Let us find the derivative. So the function f of x is given to be integral 0 to x f of t dt. So let us find its derivative. So f dash x, so that equals, just substitute the upper limit, the integration is gone, so f of x. So the derivative of the function capital F of x, this small f of x, so that is already given in the question, x minus 1, x minus 2, x minus 5. We want the derivative to be 0 for finding the maximum minimum values. So which means the maximum minimum values occur at the point say 1, 2, 5. That's it. But at which point it is maximum, which point it is minimum, you have to find the second derivative, or we have to use the first derivative test, whatever. But we're not going to use any of this. Simply let us draw the graph of the derivative of the function. So 1, 2 and 5. Now here this is an odd degree polynomial, so leading coefficient is 1, so that means as x tends to infinity it is infinity. So here something like this. Let us use the first derivative test here. Okay, so that will be easier to deal with. See, 1. At 1, is it minimum or maximum? So this is not the graph of the function f of x. It is the graph of the derivative. Okay, so here at 1 it is minimum or maximum. At 1 the derivative is 0. So it may be minimum or maximum. So let us check whether it is minimum or maximum. At 1, so before 1 it is negative, right? Derivative is negative. After 1 it is positive, negative to positive. So when the derivative changes from negative to positive, so that is the point of minimum. When the derivative changes from positive to negative, so that is the point of maximum. Similarly, this is minimum, which means at the point 1 it attains the minimum value, at 2 it attains maximum value, at 5 it is minimum value. So this is the derivative of f dash of x, right? Not f of x. Okay, so that's all. So this is the that is one thing, right? It attains minimum value at 1 and 5 and maximum value at 2. Now we also have to check whether this function f of x becomes 0 at some point between 0 and 5 or not. Alright, so we have to find the function f of x here. So f of x is given as an integral of f of t. You have to find the integration. See, at 2 the function attains minimum value. So the graph may be like this. So if you draw y equal to f of x, so that graph may be like this. See, at 1 it attains a minimum value. At 1, 2 and 5. At 0, what is the value? So the value of the function at 0 is 0, right? 0 to 0. So that is 0. At 0, it is 0. Okay. At 1, it is minimum value. At 1, it attains a minimum value. At 2, it attains maximum value. At 5, it is again minimum value. So the graph may be something like this. That means between 0 and 5, there is no point at which this function becomes 0, because this does not intersect x-axis. So at no point between 0 and 5, the function becomes 0. You understand? But is this the actual graph of the function? What if the graph is something like this? It goes above and this. So in that case it will intersect at 2 points, but we are not sure. So we have to find the value of the function at 2, right? Find the value of the function at 2. Then if that value is negative, then it is below this. That means at no point it becomes 0. If the value of the function at 2 is greater than 0, that means it becomes 0 at some point in between 0 and 5. So what we have to find is f of 2. What we have to find is f of 2. Check whether it is negative or positive. What is f of 2? So integral 0 to 2, then that value, right? So t minus 1, t minus 2, t minus 5, so dt. So here it involves some kind of integration is required here. So let us find this integration and check whether this value becomes 0 or not, or if this value is negative or positive. Okay, let us find the value of this. So to find the integral, I'm not going to do the integration. So we can, if you know the integration, we can simply do this. Otherwise, we can leave it for now. So this value is less than 0 if you find the integral. Because it is integral, now we are doing differentiation. So I'm just writing this directly. So less than 0. But it is very simple. Once you know integration, so simply integrate it. You will get a value which is less than 0. So this f of 2 is less than 0. That means the graph of this function is below x-axis. Now you tell me, is there any point between 0 and 5 at which this function becomes 0? No point, right? So this function does not have any root between 0 and 5. So that means f dash of x is not equal to 0 for x belonging to the interval 0, 5. So that's also, that is also one of the options given here. So that means, so this is our required answer. Which of the following options are correct about the function given below? Here the function f of x is given in different intervals. We have to first find the derivative of the function. How will you find the derivative of this function? You simply have to differentiate each of these expressions given in the question. Not to waste time, I've kept the derivative of the function ready-made. So this is the derivative of the function, right? So x to the power 5. So that is derivative 5x to the power 4, etc. Right? So we found the derivative of each of these expressions. So that is the derivative of the function f dash x. But when you differentiate a function like this, you have to be careful with this sign here, inequality. See, you should not put equality sign here. So even though in the question there is equality, so you should not put equality, because at that point we don't know whether the function is differentiable or not. See, for example, we found the derivative. What is the left hand derivative at 0? Substitute here 0. So you're getting 3, and substitute 0 here. So that is minus 1. So minus 1 is the right hand derivative at the point 0, and left hand derivative is 3. They are not matching. That means the function is not differentiable at the point 0. So that means you should not put equality sign. If you put equality sign here, we assume that the function is differentiable at that point, but we don't know. So you have to put strict inequality. Do you understand? But on the other hand, if you substitute 1 here, left hand derivative at 1, here 2 minus 1, that is 1. 1 is the left hand derivative at 1. Similarly, here you substitute right hand derivative at 1. So there we get 2 minus 8 plus 7, that is 1. So same value. So it is matching here. That means at the point 1, the function is differentiable. Now we can put equality here. But when you differentiate, we don't know whether the function is differentiable at the junction point or not. So we should not put equality here. But after we verify the left hand derivative and right hand derivative, they are equal, then you can put equal to sign here. You understand? So anyway, so we found the derivative of each of these expressions. Okay, so this is the function f dash of x. Let us draw this function to get an idea. So let us draw this function y equal to f dash x. Let us draw this. Okay, so this one. So how will you draw this? At 0, what is the value? Or close to 0, the value is 3. And is this expression always positive? Okay, if x tends to negative infinity, when x is minus infinity, as it is even power, so this tends to infinity only. So for negative infinity, this tends to infinity here. But is it always positive? For example, if you substitute the value of x to be say minus 1, so what will you get? 5 minus 20 plus 30 minus 20 plus 3. So that is 30 minus 40. So that is minus 10. So plus 8, so it is 2, sorry, minus 2, so this is negative value. So at the point minus 1, we are getting negative value, okay, which means it is not always positive. For some values it is negative. We don't know the exact shape of the curve, but something like this, for some values it is negative, so not always positive. Okay, now let us draw this. 2x minus 1. At 0, the value is minus 1. And it is a linear curve, right? So simply we have to draw the line. So at 1, this value is 1. So at 1, this value is 1. So it is a straight line. And similarly, so this expression, that is a quadratic expression from 1 to 3. So let us draw this. Now, so where is this function minimum? Alright, so let us find the derivative of this. This is 4x minus 8. So equate that to 0, we'll get x equal to 2. 2 is the point at which the function attains minimum value. So that means the graph will be something like this. Okay, so this is the graph. It's a quadratic curve, so parabola. Okay, done. Now log x minus 2 at 3, what is the value? Log 1, 0. Here. And it is an increasing function, right? So greater than 1, so that means log is positive. So it is an increasing function, something like this. So it goes to infinity. Okay, so here it is like this. Now we have drawn the graph of f dash of x, not f of x. So y equal to f dash of x. Okay, yes. Now let us verify whether these options are correct. So first of all, so you tell me whether this function is always increasing. No, not f dash of x. F of x is always increasing or not for negative values of x, minus infinity to 0. That means this value should always be positive. Only then it is an increasing function. But is it always positive? No. For some values it is negative also. So the derivative is negative for some values. So that means it is not an increasing function. For x less than 0, it is not an increasing function. No. And similarly, so the next option. Alright, yes. Now at the point 1, the derivative of the function, this is f dash of x. Is it differentiable? No. Because at 1, there is a sharp corner, right? Like it is not a smooth curve, right? That means it is not differentiable at the point 1. So at 1, the function is not differentiable. F dash of x is not differentiable at 1. Does it attain local maximum at the point 1? Yes, because see at 1, this is the maximum value. So it attains maximum value, local maximum value at the point 1. So that is correct. Now f of x is onto or not. So that you have to check. But we have only drawn the graph of f dash x. We don't know about f of x. Is f of x onto or not? So let us draw f of x also here. See y equal to f of x. Okay, roughly. So we need not draw the entire function. So we have to get an idea whether this function takes all values from minus infinity to infinity. So that's what we have to find. Okay. Now, so what is the graph of the function? Okay, let us. At 0, what is the value? At 0, the value here is 1, right? So here. And also it is an odd degree polynomial, which means when x tends to minus infinity, this will tend to minus infinity. Okay, whatever is the shape of the curve doesn't matter, but when x tends to minus infinity, this value becomes minus infinity, because that means the lowest value, so that is minus infinity. Okay, done. So that is the graph for negative values of x. For positive values, we will not draw the curve completely. Let me take the last part of the function, right? So that means when x is greater than 3, okay, at 3 what is the value? So that is log 1. So log 1 is 0, 0 minus 3 plus 10 by 3. So that is 1 by 3, something like this here, 1 by 3. And then, so that is an increasing function, right? Because log, this is the derivative of the function for greater than 3. So this is a function that is always positive, right? So log of greater than 1, this number is greater than 1. So that means it is always positive. So that is an increasing function, maybe like this. So it reaches infinity. So now tell me, so whether the range is from minus infinity to infinity. Does it cover all the values? So here it is from minus infinity. So minus infinity to 1, and here again it starts from 1 by 3 to infinity. That means no value is left out. It covers all values from minus infinity to infinity. That means the range of the function is minus infinity to infinity. That means this function is onto. Do you understand? So that means f of x is an onto function, and also the derivative of the function at 1 does not exist, not differentiable, and also it has a local maximum at the point 1. So that is the answer. If the function f from R to R is a differentiable function such that f dash of x is greater than 2 f of x for all x belonging to R, and f of 0 is 1, then so the derivative of the function f of x, that is f dash of x, is given to be greater than 2 times f of x. Using that, we have to find the condition satisfied by the function f of x. Alright, so what is given here is this one, f dash of x minus 2f of x. So that value is greater than 0. So this is what is given in the question. Now what you do, so this whole thing is the derivative of some function. See, this step is important. The next one, so you multiply this expression by e to the power minus 2x. 2e to the power minus 2x f of x. So this is greater than 0. See, when you multiply this value e to the power minus 2x, only then this whole thing will become the derivative of some function, right? So this step is as a part of the differential equation. When you want to solve linear differential equation, this is the idea we use here. Alright, so if you do this multiplication, this is the derivative of this whole thing will become the derivative of the function e to the power minus 2x multiplied by f of x. So d by dx of this whole thing. Do you understand? So what is the derivative of this? So product rule, e to the minus 2x multiplied by f dash x, and then f of x multiplied by the derivative of this. So the whole thing is the derivative of this expression. So that is given to be greater than 0. So the derivative of this function is greater than 0. So what does it mean? The derivative of a function is greater than 0. That means the whole function here. So that is an increasing function. So e to the power minus 2x f of x is an increasing function. So for values of x greater than 0, so if you apply this function, so same inequality is retained, right? Because it is an increasing function. So x is greater than 0, e to the minus 2x f of x is greater than, so e to the power 0 f of 0. Alright, same inequality, greater than, because it is an increasing function. For decreasing function, so this will be reversed. So now we get the value of f of x. So this is given as 1. So is greater than e to the power 2x. That's all. So this is the relation satisfied by the function f of x. For positive values of x, f of x is greater than e to the power 2x. And also, what is f dash of x? It is given that f dash of x is greater than 2 f of x. But f of x is greater than e to the power 2x. That means f dash of x is greater than 2e to the power 2x. Right? But e to the power 2x, that is always a positive value. So the whole value is greater than 0. So f dash of x is greater than 0. So that means we can also conclude that f of x is an increasing function. So f of x is also an increasing function. So that's also, that is also one of the options given. So f of x is an increasing function, and also f of x is greater than e to the power 2x for positive values of x, right? So that's it. The function f of x is given by the determinant when which of the following statements are true. Here a function f of x is given in terms of a determinant. We have to find the value of this determinant, right? And then find the derivative. We can directly find the derivative of the determinant also, but that will become very complicated. We can only differentiate one row at a time or one column at a time. It will become 3 determinants. We will not do that. We will first find the value of the determinant and then find the derivative. But that is also complicated. So we will do this one. See, First of all, from column 1 you subtract column 2, c1 minus c2. So to make it easier, right, so we want to get as many zeros as possible. So then the function f of x will become, so first column minus second column, so that will become cos 2x minus cos 2x, so that is 0. This will become minus 2 cos x and then 0. Okay, so first column. The other columns remain the same. So here it is cos 2x, sin 2x, similarly here cos x minus sin x, and then sin x cos x. So this is the determinant whose value we have to find it. Okay, so let us simplify this. So now it is easier to expand this determinant using the first column because 2 zeros already. So this becomes, so 2 cos x multiplied by, so this product, right, so we have to multiply this. So what is this product? Cos 2x cos x minus sin x sin 2x. Isn't it like sin a cos b minus sin a sin b? Cos a cos b minus sin a sin b, that is cos a plus b. So this will become simply cos a plus b. So 2x plus x, cos 2x plus x, isn't it? Cos a plus b. So it is cos 2x cos x minus sin 2x sin x. Do you understand? So our function is simply 2 cos x multiplied by cos 3x. Okay, so this is the function f of x. Now we have simplified the determinant and we got the function in terms of a simple expression. Okay, now we have to find the minimum, at which point the function attains minimum or maximum values. Okay, right. Now see, we are not going to find the first derivative, second derivative to check minimum or maximum. You see, at zero we want to check whether this function is minimum or maximum, right? See, that is very obvious, right? So what is the maximum value of this function? That is 1 cos x. Similarly, this also has maximum value 1, but this is maximum at 0. When x is 0, cos 0 1. Similarly, cos 0 1. So the maximum value of the function is 1 multiplied by 2. So 2 is the maximum value. That happens when x is 0. So when x is 0, at x equal to 0, f of x is maximum. Not only 0, at even multiples of pi, right, but we only want the point 0. So at 0 the function attains maximum value. So that is one of the options, right? Yes. Now let us find the derivative. Now we have to find the derivative. So we also have to find the number of roots of the derivative. For that, let us find the derivative. Before finding the derivative, we will further simplify this. F of x is equal to, it is again of the form 2 cos a cos b, right? 2 cos a cos b can be written as cos a plus b plus cos a minus b, right? 2 cos a cos b. So that is cos a plus b. A plus b is what? X plus 3x. So that is 4x plus cos a minus b. So that is cos 2x. So this is the function f of x. We only simplified f of x. Now we will find the derivative. So f dash x. So that equals, let's find the derivative, minus 4 sine 4x minus 2 sine 2x. Okay. Now we have to equate this to 0 and find the solutions. Okay. So let us take this common. Again, sin 4x can be written as 2 sin 2x cos 2x, right? Sin 2a formula. So this will become minus 8 sin 2x cos 2x minus 2 sin 2x. So we can take out the common factor. So that is minus 2 sin 2x multiplied by, so this will become 4 cos 2x plus 1 equal to 0. Alright, so now we'll find a solution of this. So either sin 2x is 0 or this cos 2x equals minus 1 by 4. So sin 2x equals 0. So that means what can be the value of 2x? 0, or it can be pi, any multiple of pi. But x lies between minus pi and pi. So that means 2x lies between minus 2 pi and 2 pi. So 2 pi you should not take, right? Open interval. It can be minus pi. So that means x can be 0, pi by 2 and minus pi by 2. These are the solutions of this equation. Similarly, we have solutions of this equation. There are many solutions here, right? But definitely it will have some solution, right? Not 0, right? So this will have more than one solution. Already we have 3 solutions. So totally this equation has how many solutions? Definitely more than 3. So that means, so this has more than 3 solutions. More than 3 solutions. So this equation f dash of x equal to 0 has more than 3 solutions, and also x equal to 0 is the point of maximum for this function f of x, right? So that means, so that is the answer. if the function f from R to R is a twice differentiable function such that f double dash of x is greater than 0 for all x belonging to R, and f of 1 by 2 is 1 by 2 and f of 1 is 1, then here the second derivative of a function is given to be greater than 0. What does it mean the second derivative is positive? See, it's given that f double dash x, right? So that is greater than 0. So this means the first derivative of the function, that is f dash of x, so that is an increasing function, because the derivative of f dash of x, so that is f double dash of x, so that is given to be positive. If the derivative of any function is greater than 0, that means that is an increasing function. So f dash is an increasing function, alright? Yes. Or we can say that when the second derivative is positive, that means it is a concave function. F of x is a concave function, like this. The shape will be like this. We can also use the idea of concavity to solve this question, but we will not do that. We will simply use the idea of the Lagrange's mean value theorem. Okay. What is Lagrange's mean value theorem? In the interval 1 by 2 comma 1, right? Because those values are given, f of 1 minus f of 1 by 2 divided by 1 minus 1 by 2. So this equals f dash of c for some value of c belonging to the interval 1 by 2 comma 1, right? For some value of c, the derivative f dash of c is equal to this value. But f of 1 is given in the question, 1, and similarly f of 1 by 2 is 1 by 2 divided by 1 by 2. That equals f dash of c. So we've got the value of f dash of c. So that equals 1. So f dash of c is 1. But c lies in the interval 1 by 2 comma 1. That means c is less than 1. So 1 is greater than c. When 1 is greater than c, what about f dash of 1? So that is greater than f dash of c. Same inequality, because f dash is an increasing function. It is an increasing function, so same inequality, right? Yes. So that means f dash of 1 is greater than, say, f dash of c. So that's what we found here. So greater than 1. That's all. So that is our required answer. Simply the derivative of the function at 1 is greater than 1. So that is the answer. Let f of x equal to x plus log x minus x log x for x belonging to the interval 0, infinity. Column 1 contains information about zeros of f of x, f dash of x and f double dash of x. Column 2 contains information about the limiting behavior of f of x, f dash of x and f double dash of x at infinity. Column 3 contains information about increasing, decreasing nature of the function f of x and f dash of x. Then answer the following questions. This is one hell of a question. This looks like a matrix match, but it is not. These columns are not at all related. You have to do all the 12 questions separately. So there are 12 questions to be solved. Let us do it one by one. F of x equal to x plus log x minus x log x. So this is the function given. Let us find its derivative. F dash x equal to 1 plus 1 by x minus product x 1 by x. That is 1 minus log x. So that means, so this gets cancelled. So 1 by x minus log x. So that is the derivative of the function f dash of x. Is it always positive or always negative? If it is always positive, then f of x will be an increasing function. But is it true? So 1 by x, is it greater than log x always? So let us have some idea by drawing the curve. So this is a graph of 1 by x. Okay, this is 1 by x curve, right? Xy equal to 1, like a rectangular hyperbola. And log x curve is like this. Now at 1, this intersects x-axis. Now at some point, these two curves intersect. That means what? Up to that point, 1 by x is greater than log x. That means this is positive up to that point. And after that point, so this becomes negative. So this point is less than e, right? Because at e, 1 by x is smaller. 1 by e is smaller than log e, which is 1. So that means at e, 1 by x or 1 by e is less than log x. That means this becomes negative. Okay, we'll use it later when required. Now we'll also find the second derivative. What is the second derivative? So that is minus 1 by x square minus 1 by x, right? That is the derivative of this. But this is always negative because x is positive anyway. So 1 minus 1 by x square, negative, negative. So this is always negative. That means f dash of x is a decreasing function because it is negative. So the first derivative function f dash of x is always a decreasing function. Okay, so that means so f dash is decreasing, but we don't know about f of x. Okay, that depends on the value of x. Alright. Now we will answer the questions one by one. So the first question, we want to check whether the function f of x can be 0 at some point between 1 and e square, right? So it is difficult to draw the graph of f of x. Alright, so let us use some other method. Let us substitute the value, right? 1. Let us substitute 1. So if you substitute 1, f of 1, what is the value of f of 1? 1 plus log 1 is 0, 0. So f of 1 is 1. And what is the value of f of the right hand point? E square. So that has value e square, log e square is 2 minus e square 2. So it is e square plus 2 minus 2 e square. So that is 2 minus e square. This value is negative. Alright, so 2 is less than e square. Alright, now that means at 1 it is 1 positive. At e square it is negative. So that means the graph will be something like this. At 1 it is a positive value. At e square it is a negative value. That means the graph will definitely intersect x-axis at some point. It is a continuous function. That means so there will be one point at which it becomes 0. Alright, so that means first option is correct. So do you understand? So these two have opposite signs. There will be definitely one point at which it intersects x-axis. Alright, so that is correct. Now similarly, let us check the next one, second one. So what is the second one? F dash of x is 0 at some point of it. Same method we will use. So f dash of 1. What is f dash of 1? So f dash of 1 here, so it is 1 minus log 1 is 0, 1. What is f dash of the right hand point is e? So that is 1 by e minus 1. So 1 by e minus 1, that is negative. Again same rule, right? So f dash of 1, for one value it is positive or one value it is negative. That means between these two values there is a point at which it has some root. So that means so this is also correct. Do you understand? So simple idea. So the two signs are opposite. There must be some value between these two values at which it crosses x-axis. Okay, third one. So f dash of x is 0 for some value between 0 and 1. So let us check. So some value. What is f dash of 0? So f dash of 0 is 1 by 0. Okay, that is infinity. Alright, so this is minus. So it tends to infinity. Okay, so this value tends to infinity. Okay, so f dash of 0 tends to infinity. Now the right hand point, f dash of 1. So what is f dash of 1? So that is 1 minus, again log 1 is 0, so 1. So both are positive, right? It is a positive infinity and also here positive value. So that means it will be like this. So at 0 it is infinity, at 1 it is 1. Okay, which means there is no root. Because it is a decreasing function, remember, so it is not possible that it comes down and it will go up. No, it is not possible because the second derivative is negative. That means it is a decreasing function. So but these two values are positive. That means there is no root. At no point between 0 and 1 it intersects x-axis. Do you understand? That means no root for the function f dash of x in the interval 0 to 1. Okay, so third one is also done. Okay, now the fourth one. So what is the fourth one? F double dash of x equal to 0. Does it have a root? No, obviously, because f dash of x, f double dash of x is always negative. Okay, that's what we have proved here. It is always negative. It is never 0. So for no value, this second derivative is 0. So that means so that is also not correct. So only first option and second option are correct. The first column. Alright, now we will take the next column. Okay, yes. So the first question is limit x tends to infinity f of x, right? F of x is this function. What is the value of this function as x tends to infinity? So x tends to infinity. So infinity minus infinity. Infinity minus infinity. That is indeterminate form, right? So we have to try something else. We should not directly substitute. So what we can do is we can factorize it, right? If you factorize it from these two, we can take x common. So it will be like this. X minus 1 multiplied by 1 minus log x. Isn't it? This multiplication only this one. So x multiplied by 1 x and x multiplied by minus log x and then minus 1 and then minus 1 multiplied by log x, so plus log x, but minus 1 multiplied by 1, so that is minus 1, so that term is not there, so we have to write plus 1. Okay, so now it is correct. Now it is easy to find the limit. See, now substitute infinity. What is infinity minus 1? Infinity, and 1 minus log infinity, so that is infinity. So this whole thing becomes minus infinity, so this is plus infinity, so this value tends to minus infinity. You understand? So infinity, this minus infinity, so minus. So minus infinity is the value, so that means the first option is not correct, but the second one is correct, right? Limit x tends to infinity, f of x is minus infinity. Okay, so first one is not correct, but the second one is correct. So limit x tends to infinity, f of x, So that is minus infinity. Okay, now the third one, f dash of x, right? Limit x tends to infinity, f dash of x. Okay, so limit x tends to infinity, f dash x. So we found f dash of x here. So when x tends to infinity, 1 by infinity, 0 minus log infinity tends to infinity. So 0 minus infinity. So that is minus infinity. Okay, so that is correct. Last one, limit x tends to infinity, f double dash x. So that is simple. So limit x tends to infinity, f double dash x. So that is known. So when x tends to infinity, 1 by infinity. So that is 0. So this is also 0. So that means the whole thing becomes 0. So 0 is the value of this thing. Okay. Now the next column. So P. Okay. So f is increasing in 0, 1. In that interval is f increasing. See 0, 1. See, we know that 1 by x is greater than log x, right? So f dash of x is 1 by x minus log x, but that is greater than 0 in the interval 0 to 1. Because between 0 and 1, 1 by x is greater than log x. That means this value is positive. That means it is an increasing function. That means this is correct. Okay, it is an increasing function. Now f is decreasing in the interval e comma e square, right? So e to e square. So e to e square, that means more than e. So when x is more than e, so which is bigger? Log x is bigger than 1 by x. So log x is bigger. That means this value is negative. So in that interval, f dash of x is negative in the interval e to e square. That means it is a decreasing function. So that is also correct. Yes. Next one, f dash is an increasing function. Yes. R. So this is correct. Now f dash is an increasing function. Let us see. What is f dash of x? So this one. Now f double dash of x is what? Negative. That means it is always decreasing. Whatever is the value of x, so it is always decreasing. Because f double dash of x is negative, that implies f dash of x is a decreasing function. Decreasing function for any value of x greater than 0. Okay, so that is not correct. Now last one. So f dash is a decreasing function. So that is correct obviously, because for all values f dash of x is decreasing function. F dash of x is decreasing for all values. For all x greater than 0, particularly in that interval e to e square, it is a decreasing function. Do you understand? So that means so that is the correct option. Alright, yes. Now we're done with all these options. Now it is for you to go through these questions and select the correct combination, right? So this is the answer. Let f from r to 0, infinity and g from r to r be twice differentiable functions such that f double dash and g double dash are continuous functions on r. Suppose f dash of 2 equal to g of 2 equal to 0, f double dash of 2 not equal to 0 and g dash of 2 not equal to 0. If limit x tends to 2, f of x, g of x divided by f dash of x, g dash of x equal to 1, then here the limit of some expression is given. See, it is given that limit x tends to 2, f of x, g of x divided by f dash of x, g dash of x. So this limit is given to be 1. So that means this limit exists. See, when you substitute 2 here directly, f of 2, g of 2 divided by, so f dash of 2, g dash of 2. But it is given that g of 2 is 0 and f dash of 2 is also 0. That means it is of the form 0 by 0. So 0 by 0 is one of the indeterminate forms. That means we can use L'Hopital rule. So let us use L'Hopital rule. Let's find the derivative of the numerator and denominator separately. Okay, so what is the derivative? We have to use the product rule. F of x multiplied by g dash x plus g of x multiplied by f dash x. So that is the derivative of the numerator. Similarly, denominator. So f dash of x multiplied by the derivative of this, that is the second derivative, plus g dash of x multiplied by the derivative of that, f double dash x. Okay, so this is the derivative. Now you substitute the limit. Now if you substitute 2, again this g of 2 is 0, so this term will become 0. Okay, and similarly denominator, f dash of 2 is 0, so that means f dash of 2 is 0, so this term becomes 0. Okay, now you divide that, so we get limit x tends to 2. What do you get? F of x, g dash of x. Here g dash of x, f double dash, so g dash cancels, so that means we'll get f of x divided by f double dash x. So this limit is what is given as 1, right? Okay, so this limit is 1, but now if you directly substitute f of 2 divided by f double dash of 2, so that is 1, so that means f of 2 equals f double dash of 2. Okay, now the function becomes 0, f of x becomes 0 at the point 2, right? The function becomes f dash of 2 is 0, right? F dash of 2 is 0, that means the function may attain minimum or maximum value. Is it minimum or maximum? That depends on the second derivative, right? If the second derivative f double dash of 2, if it is positive, then we have minimum value. If it is negative, it has maximum value. But is it positive or negative? So that depends on f of 2. Is f of 2 positive or negative? See, it is given that f is a function which has codomain 0 to infinity, which means f of x has range positive values only, no negative value. F of 2 is always positive. So that means f double dash of 2 is also positive. So this value is positive. From the codomain given in the question, so we can understand that, so this value has to be positive. That means this 2 is not the point of maximum, it is a point of minimum, because second derivative is positive. So that means x equal to 2 is a point of minimum. Do you understand? So this is a point of minimum. So that's all. So that is one of the options here. And also, so this function f of x minus f double dash of x equal to 0. This is satisfied by some value, right? What value? This is very obvious here. F of 2 is equal to f double dash of 2. That means, so this x equal to 2 is a solution of this. So f of x minus f double dash of x equals 0 is satisfied by this value x equal to 2. That means, so that is also correct. So this must be the answer. The least value of alpha for which 4 alpha x squared plus 1 by x greater than equal to 1 for all x greater than 0 is. Here some inequality is given which is satisfied by all values of x greater than 0. Using that, we have to find the minimum value of the alpha given in the question. Alright, yes. So what is given here is 4 alpha x square plus 1 by x. So this is greater than equal to 1 for all values of x greater than 0. Okay, so that means this function has minimum value 1. So 1 is the minimum value of this function. So what we have to do? We have to find the derivative of this and find the minimum value, and that value is 1, right? So derivative method can be used here. But instead of derivative method, we will use a different method, right? So we can use the arithmetic mean, geometric mean, because there is x square and the reciprocal, right? 1 by x is also there. So we'll use the concept of arithmetic mean greater than equal to geometric mean. So for using that idea, we'll write this expression as, instead of 1 by x, we'll write it as 1 by 2x plus 1 by 2x. Okay, so that sum is equal to 1 by x. Why? When you find the geometric mean, so x squared, that will get cancelled, right? So we'll use the concept of arithmetic mean greater than equal to geometric mean. All these values are positive, remember. So then only then we can use this idea. So am greater than equal to gm. So what is arithmetic mean of three numbers? A plus b plus c divided by 3 is greater than equal to cube root of the product of numbers a, b, c. Okay, so a plus b plus c from this is greater than equal to 3 multiplied by cube root of ABC. So let us use this idea to find the minimum value of this one. Okay, so here it is like A plus B plus C. So that is greater than equal to, so let us write it. So 4 alpha x square plus 1 by 2x plus 1 by 2x. So just like A plus B plus C. So that is greater than equal to 3 multiplied by the cube root of ABC. ABC means the product. So 4 alpha x square multiplied by 1 by 2x multiplied by 1 by 2x. So that means this value is greater than equal to 3 multiplied by, so this gets cancelled, right? X square gets cancelled. So this 2 to 4 also gets cancelled. So this is cube root of alpha. Okay. So that means this is greater than equal to, so this value must be greater than equal to 1, because it's already given that this expression is greater than equal to 1, but we have got that this expression is greater than equal to this value. So that means, so 3 multiplied by cube root of alpha, so that value must be greater than equal to 1. Only then this inequality will be satisfied, right? Yes, simplify this, you cube this, so alpha is greater than equal to 1 divided by cube of this, so that is 27. So that's all. So that is our answer. So the value of alpha must be greater than equal to 1 by 27. That means the least value of this alpha is 1 by 27. So that is our answer.